All right, so let's take a look at solving inequalities. This has been pretty confusing for everybody, so let's figure it out. List three values for y that would make the inequality 3 is greater than y plus 2 true. Explain how you know. Okay, so three values. That's what I need to find for y, this guy, that would make this a true statement. So, I can think of a lot of numbers like 10, 20, 100. Um, Also, 2, but not 1, because that would be 3 is not greater than 3, so that wouldn't be true. If I picked 1, and instead of y, I wrote 1, this is not true. 3 is not greater than 3. So 1 would not work. So list three values. I can list a lot. Basically, anything greater than 2 would work all the way to infinity. All right. Then we have, solve the problems below. Then graph your solution on the number line. Explain how you found the solution and justify how your number line represents the solution. That sounds confusing, but once you know how to do these, it isn't. So solve lets me know that we need to know what this unknown is. So I'm solving an inequality. I'm solving kind of like an equation. So x minus 5 is less than or equal to 3. To isolate a variable, which is that guy, we have to do the inverse operation to whatever is here. This is like saying minus 5, so I'm going to add 5. So if I had a balance here, and I had some block, minus 5, I guess, and then on the other side, 3. If I were to add 5 to both sides, this would still be balanced. It wouldn't, if it were balanced before, it would still be balanced. So these will cancel out to be 0. So it's like plus 0, but I don't need to write plus 0. I can just say x is less than or equal to, and then I added 5 to 3, 8. So x is less than or equal to 8. And what does that look like? Well, I guess if 0 is here, 2, 4, 6, 8. X will be less than or equal to 8. So I colored in this dot to indicate that x, which is the line, so this is x. X is all of these numbers forever and ever and ever, up to 8, including 8, but nothing over 8. I found my solution by um, isolating the variable. Okay, so the next question is, the graph represents the solution because n plus 4 is greater than negative 5. I don't know what n is, but I know that since I know how to balance equations, I can balance inequalities the same way. So this cancels out. negative 5 minus 4 equals negative 9. So n, this just keeps dropping down, is greater than negative 9. So where's negative 9? Let's make it here. Why not? And then negative 7, negative 5, negative 3, negative 1, 0, 1, 2, 3. So if it's greater than negative 9, it's going to be all of these numbers. So n represents these numbers, but not negative 9. I found my solution by same thing. The graph represents the solution because there is a line above all possible solutions. It's approaching negative 9, but not touching negative 9. Negative 9.00001 is fine. Or negative 8.99999. Not the other way. Forgot how negative numbers work for a second. Okay, solve the following for variable t. We have two negatives here. We have subtracting a negative 4. So what if we add a negative 4? Wouldn't that be the opposite? So t minus t negative 4 is greater than or equal to 11. So why don't we add negative 4 to cancel out and add negative 4, which is really subtracting 4. So t is greater than or equal to 7. So you could rewrite this as t plus 4 is greater than or equal to 11. T is greater than or equal to 7. If you subtract the 4 from both sides, you could just subtract 4. That is more how I would do it, is rewrite it as subtracting a negative is the same as adding a positive, so t plus 4, then just subtract 4. Explain the steps you use to solve the inequality. Basically, that rewrote the subtracting negative 4 as adding 4. And then solved. Isolated the variable, did the inverse operation, and solved. Write an inequality that represents the graph in two different ways. Okay, so what do I want to call this line? Let's call it W. I think W is a good letter. So W, what is W? W looks like it's everything that's more than 4. So W is greater than 4. Does it contain 4? Yes, it does. So one thing about inequalities is you can read them from left to right. They're also true if you read them backwards from right to left. So 4 is less than or equal to W, like a mirror image almost of that. So, whoops. So W is greater than 4. Check, that's right. And 4 is less than or equal to W. That's true also. Another one, I guess, would be 3 is less than W. W is greater than 3.